In Unit 3, we're switching gears a little bit. In this unit, we're going to talk about conditional statements, reasoning, and proof. All of these will be extremely useful in the units to come. So first, let's talk about a conditional statement. A conditional statement is a statement that is written in if-then form. The hypothesis is known as the if part of the statement. The conclusion is known as the then part. If you remember, the conclusion always comes at the end of a story or the end of an experiment, so the conclusion always comes at the end of the statement. Let's look at an example. So you can start out with a statement, a rectangle has 4 right angles. If we can turn that into a conditional statement by putting it in if-then form. So if a figure is a rectangle, then it has 4 right angles. The hypothesis is going to be the words that are following the if. So in this case, the hypothesis is a figure is a rectangle. The conclusion is going to be what is following then. So therefore, the conclusion here is it has 4 right angles. In our second example, our statement is a number ending in 0 is divisible by 5. We can turn this into a conditional statement by saying if a number ends in 0, then it is divisible by 5. The if part is my hypothesis, so therefore it is a number ends in 0. And the conclusion is the then part, which is it is divisible by 5. An important vocabulary word that we need to remember is negation. Notice it sounds like the word negative. If something is negative, it is opposite. So negation means to give opposite meaning. Typically, when we're talking about our statements, it's going to be adding the word not. So a conditional statement is just an if-then statement, the hypothesis being the if part, the conclusion being the then part. We also have what we call related conditionals. These are the converse, the inverse, and the contrapositive. The converse switches the hypothesis and the conclusion. The inverse makes both the hypothesis and the conclusion not. Therefore, it's negating those. So it adds the word not to both parts. And the contrapositive does both. It changes the hypothesis and the conclusion to nots, and it switches the hypothesis and conclusion. So let's look at an example. My original conditional is if the month is February, then it has 28 days. Now, notice below we also have room for a truth value. And the truth value is basically just stating, is it true or false? However, if it is false, we do have to provide what we call a counterexample, which is just an example proving that it is false. So if the month is February, then it has 28 days. This would be false, because the month of February in a leap year can have 29 days. So our counterexample is if it is a leap year. The converse is switching the if and then of the original. So the converse of this statement would be if a month has 28 days, then it is February. Again, this is false because of the leap year. The inverse is if the month is not February, then it does not have 28 days. And this is true. The contrapositive, if the month does not have 28 days, then it is not February. This is also false, again, because in a leap year, February has 29. In the next example, my original conditional is if 2 angles form a linear pair, then they are supplementary. Remember that a linear pair are angles that are adjacent and supplementary. They're creating a line. So yes, if 2 angles form a linear pair, then they are supplementary. It is true. The converse, we're switching the if and then. So if 2 angles are supplementary, then they form a linear pair. Recall that supplementary can be any 2 angles that add to 180 degrees. They do not necessarily have to be adjacent. So therefore, this is false. And our example can be a picture. because you can have a 110-degree angle and a 70-degree angle. Those are supplementary, however, those do not form a linear pair. If we look at the inverse, if two angles do not form a linear pair, then they are not supplementary. If we think about this one here, if they are not a linear pair, then they are not supplementary, but that's not necessarily true because they can be supplementary without forming a linear pair. So this one is false, and again, you can show two angles that are going to be supplementary, however, that are not that linear pair, for instance, two right angles. And then the last one, your contrapositive both switches and changes them both to not. So if two angles are not supplementary, then they do not form a linear pair. And this is true. In order for them to form a linear pair, they must be supplementary. The last type of statement that we want to talk about is a biconditional. Think the word prefix bi means to. So a biconditional statement has two meanings. It's going to be recognized because it's going to have the phrase if and only if contained within the conditional. Keep in mind that in order for the biconditional to be true, both the conditional and its converse must be true for the biconditional to be true. So an example of a biconditional statement would be two angle measures are complements if and only if their sum is 90 degrees. So notice you've got your phrase if and only if. This means that both the conditional and the converse of this statement can be written. The conditional is reading it just as is. If two angles are complementary, then their sum is 90 degrees. We also want to identify the truth value, and this would be true. The converse is reading the statement backwards. You're switching it around. So it would read, if two angles have a sum of 90 degrees, then they are complementary. This would also be true. So since both the conditional and the converse are true, then we know that the biconditional is also true since both the conditional and converse are true. Now practice writing these statements on your own.